good to see some students here. So hopefully we have some carryover from the last meeting, and we'll actually build on a few of the concepts that we talked about for the math, but the primary focus today is science. Got some fun slides for you guys. We're actually going to look at a real ACT science section and dissect it. And I'm going to teach you exactly the same thing that I've taught my students at the level of tutoring that I tutor for the last 10 years. So I look forward to teaching you guys that. I look forward to any and all questions. I really do encourage you, and I'll be repeating this, to download on the class slides section the Science 2009_04 PDF, because you can use that for reference. If you have access to a printer, you can even print it out just so you have a copy in front of you. We're going to primarily work off of that today, and we're going to get going. So Anthony will be moderating the questions, and yeah, just let us know if you have anything that you're concerned about. So hopefully everybody can see the screen. What I'm going to do is take us through the slideshow like last time and talk about the ACT science. Some of what I'm talking about also dovetails with the SAT, because the SAT now includes science mini questions. So they'll have a science looking chart or graph, and they'll have one or two, sometimes even three questions about it, mixed in with the grammar and the reading, and in some cases the math section. So they have a science section, but it's spread out through the entire SAT test, whereas the ACT has a science section all in one. What's most important with the science section on the ACT, and I talked about this last time we met, is pacing. So the science section is probably the sneakiest, most difficult section of the ACT, and I actually want to just say this face to face with you guys. This is where they separate people, because what they do is they run you through an English section to start off. That's not too bad. It's 45 minutes, 75 questions, 15 minutes per passage, or sorry, 9 minutes per 15 questions, 5 passages. It's not too bad. People seem to be okay with the English. Maybe they have trouble finishing the last 1 or 2 questions, but usually they can finish. Then there's a math section, and that's kind of difficult for some people. You need to know a lot of math. There's a big umbrella of concepts that you have to have. But if you don't know a question or two, you can kind of let them go. And usually most students miss a few questions at the end. So in the last 10, it's pretty common to miss even 4 or 5 questions, sometimes 6 or 7, and still get an okay grade because the math is fairly well curved. The reading and the science are not friendly curved, and they also don't give you enough time. So the reading and science are 35 minutes for 40 questions. I think a lot of people look at the reading and science and they think it's 40 minutes for 35 questions. It's not. It's the other way around. You actually have less than 1 minute per question. And what that means is you have to keep track of your time. You need to have a watch, maybe not this kind of watch. In fact, you couldn't bring this watch into the test, but a watch like a running watch, like one of these old school digital watches. You can get them on Amazon for about $10. So just take a look. A watch that has a simple countdown timer, or a simple running chronograph, something that you can just hit start and the time runs forward, 1 minute, 2 minutes, 5 minutes, 30 minutes. And you can use something like that in the test. They are totally legitimate. There is no problem having a watch like that so long as it doesn't beep super loud. And you can use that to keep track of yourself. Or if you'd like to go old school, you can make sure that you're sitting near a clock and take a look at the clock. The only problem is that sometimes there isn't a clock in the room. So I strongly recommend that you have a watch, because again, the reading and the science are not quite enough time. They're the most time pressure sections of the ACT. So let me come back around to the slides. My apologies if I sniffle a little bit. It's allergy season, so please bear with me. Okay, hopefully everybody can see the slide again. So science, it's about 52 seconds a question. There's going to be something that we'll talk about a lot, which is S4L. S4L means save for later. If you're stuck on a question and it's taking more than a minute, you have to make a decision. Do you want to invest another 20 seconds in this question, or do you want to just let it go for now? That's going to be a theme of what we're going to talk about this evening. So here's how you can do running time on the test. This is what I teach my students. Number 1, look at the last question of the science passage. We're going to do this in a moment, but perhaps the question that is the last question of the passage would be question 22. Then you're going to subtract the passage number. So maybe it's passage 4, and the last question is question 22. You should be done with that passage by that time. So in this case, the last question is 22. The passage is passage 4, so that would be 18 minutes. You should be done with the passage by 18 minutes in this case. I'll talk about the timing quite a bit more, so bear with me if that doesn't quite make sense. I just want to reiterate, this does not work with countdown timing. So if you have a fancy ACT watch, I'm afraid that's not going to work with this type of timing. You need to watch that counts forwards, not downwards. It needs to go 1, 2, 3, 4, 5, 30 minutes, not from 35 minutes down. Is there enough time to read everything on the ACT Science? No, there is not. Yeah, unless you're a science whiz. So if you're the kind of person that just really likes reading science books, and you've always been that person, you're the kind of top 1 or 2 out of 100 in science, maybe. You might be able to read everything, and you might be able to answer all of the questions, but to be honest, even that person has a really difficult time. What you need to learn how to do well on the ACT Science is to read through only about 40% of the information, focusing primarily on charts and graphs, answers, and then if you can't find the information from those, the lab text or the intro information. And lastly, if you can't find that, you will visualize the question. Using this process, this acronym that I like to call CALI-V, you can find your way through the passages and read only about 40% of the text. And I'm going to show you how to do that on a couple of these passages that are in the April 2009 science section that you have downloaded, or sorry, the 2009-04. So once again, please take a moment to download or open up Science 2009_04 PDF. If you can't access it, that is okay, because I've photocopied and pasted a lot of it into the slideshow. Photocopy might not be the right term, but basically it's here in the slideshow. It's just nice if you have a copy of your own to look at. I also want to talk just for a moment about what we have covered before. One of the most important things is POE. This is to be used on the entire test, either ACT or SAT. You must always try to cross off the wrong answers. Don't look for the right answer. Look for the 3 wrong answers. Humans are much better at working from a 50-50 shot than a 1/4 or a 1/3 shot, and that's because of how we're designed. Humans have bilateral symmetry. That means that we have 2 ears, we have 2 eyes, we have 2 hands, etc. We are really good at weighing between 2 things. If we can get down to a choice between 2, we tend to be more like 80 or 90% accurate, whereas before, when we were between 3 or 4, we would be more like 40 or 30% accurate. So the rule of thumb is, on every question, cross off at least once. Super important. We're going to talk about that a lot today. Here's an example of POE on the science. So you guys can just take a look at this. This is actually not from the 2009-04 test, so just take a look at the slide and take a moment to read the question. It says, according to figure 1, a facies G, don't even worry if you can't pronounce the name. You can just call it an FG rock in your mind, that's fine. So an FG rock will most likely form under which of the following pressure and temperature conditions? So when I read this question, I'm thinking the terms figure 1, FG rock, and then temperature and pressure. So hopefully everyone looks on the figure and they can see the facies G over here. And they think to themselves, okay, well, we could start looking at these answers and really thinking about a lot of different things. And that would not be such a great idea. Our goal is to think about as few things as possible. What we want to do is see what we can cross off. And we also want to see if we can mark in the chart any information that we notice. One thing that we notice is that the first column in the answer choices is pressure. Well, pressure is also the y variable in the figure. So that means that if we look at facies G, there's a limit to the pressure for facies G. Apparently it's right around 10. So what I would do is make a flat line right around 10, because that's a limit for facies G. And what that tells me is that the pressure cannot be below 10. Or another way to say it is, it's certainly not going to be above 8. And what that means is we can easily cross off F and G because the pressure is too low. And between H and J, it looks like pretty clearly the answer is going to be J. That to me is using the POE process. Whenever we can, we try to mark something and then immediately go to the answers and see what we can cross off. The idea is not to try to process everything at once. If you try to process everything at once, it's like a juggler trying to juggle 10 different things. You're going to have a really difficult time. That's not to say that you cannot do it, but it is a really challenging thing to do, especially when you're feeling time pressure. What you want to do to work more efficiently on the ACT is to cross off one thing at a time and test one thing at a time, just like you would in the math. Set up the question, make your markings, cross off answers, get down to 2, and then select. That's the process. That's what we want to be working on when we practice the science. And I encourage you guys to download practice tests from the links that Anthony has provided and practice using this kind of technique. It's not about trying to do everything in your mind. If you do it in your mind, you might be correct. But what happens to a lot of students when they practice doing it in their mind is that when they take the real test, they have a really challenging time. The difference is, and I'm gonna come back to my face picture. The difference is that when people take a test for real, the anxiety ratchets up just so much more, because when you're in the room taking the test with 30 other students, and I know this because I've taken a lot of tests, even as a tutor, I've taken tests, real tests with my students, just to kind of encourage or to cheer people on. And so I've been in the room recently. It never changes. The room is always painful to be in. There are always a bunch of people sneezing and shuffling and kind of quietly freaking out. And there's a smell of sweat. And there's this general fear/irritable feeling in the room. That's going to spread to how you feel when you're taking the test. And what that means is if you're the kind of person who can juggle 5 things at once and you feel pretty good about that when you're practicing, you may not be able to do that on the real test. It's kind of like if you had to do a real performance in front of an audience of 1,000 people. Even though there's no audience in the room per se, there kind of is, because this test is a performance and there are a lot of people watching, and so it has a lot of pressure. And that's why you need to think about just doing the simple thing, just one thing at a time. And that's why POE is so important. And that's why marking on the page is so important, because you can do one thing at a time, build your way through the question, and not have to think about everything all at once. And that's realistically what you're going to find yourself needing to do when you're at the last part of a test that you've been working on for 3 hours, and when you're in that room with all those other anxious people. So again, POE, super important. And we're going to talk about that more and more as we go through these practice problems today. So I'm going to go back to the slide. All right, moving on from POE. Another thing that we've covered is POOD, your personal order of difficulty. And that's super duper important on the science as well. Just like it is in the math, and really just like it is in the reading and the English. If you find yourself stuck on a question, you should know if it's too difficult. You should know if you're getting stuck, and you should definitely have a sense of timing that says, I gotta go, I gotta go. I don't know this one. Okay, I'm just gonna let it go for now. It's all right to let go of a question. What you wanna do instead of rushing through questions is work slowly and carefully, and remember that if you can work slowly and carefully, and let go of the 1 or 2 or 5 or 10 or however many advanced sneaky questions when you run into them, then you're actually going to have a much higher scoring test. People who rush and try to answer everything often end up scoring a lot lower than they're capable of. Slowing down and scoring more is the first most important thing that we have people do. And that's industry standard. Any person who does test prep is going to say slow down, score more. That's just what you have to do. That ties into your personal order of difficulty, and it ties into POE. So I'm going to reiterate. If after setup you've been stuck for 60 seconds and there's no answer in sight, don't be afraid to let it go. The acronym that I like to say is S for L, and we're going to talk about that again as well. It's also important to remember there is no penalty for guessing, so you definitely should guess. Don't leave anything blank. But do the easy test first. So if you're stuck on a question and you just can't figure it out and you can't even cross anything off, well then come back and take your best guess right at the end. Or take your best guess right then and then just don't even worry about that question. Another thing that's really important in the science that relates to POOD is the PLR. I think that's just an interesting term. PLR? What's the PLR? The PLR is the path of least resistance. This is a really interesting idea that resonates with a lot of things beyond merely the ACT science, but it definitely shows up in the ACT science. What it means to me is something kind of like fixing a broken DVD player. If your DVD player breaks and you need to figure out what's wrong with it, you're going to try a whole bunch of different things and work your way through and cross off possibilities until either you figure out that your DVD is broken beyond repair, or you find whatever button combination it is that lets it work again. Maybe a better example would be a puzzle in a box. Let's say you get a puzzle in a box and you have a 1-minute time limit. So probably the worst way to solve the puzzle would be to pull one piece out at a time and then try to put them on the table and solve that way. That might take a very long time. So I just picked this off the internet, but pretend this person is just taking one thing at a time and has at least decided to piece together the pieces for the moon. This person looks like he's in for a really difficult puzzle-solving experience because, well, he's trying to solve a night sky puzzle, so probably a lot of the pieces look very similar. Thankfully, our puzzles on the ACT Science are not that challenging. We only have a 5 to 7 piece puzzle because we only have 5 to 7 questions. Even so, there are better and worse ways to solve the puzzle. When we use the path of less resistance, what we want to do is take a look at the questions and mentally estimate their difficulty. There's a way to do this just by glancing at the questions without even reading them. You can look at the questions and sense fairly quickly which ones are going to be easy and which ones are going to be more challenging. Here's a hint. The ones that have more text tend to be more challenging. Now, that's not always the case, but usually if there's a lot of text, that's probably going to be a more challenging question. I will say that sometimes there are questions that have very little text, and those are still very challenging, and you will find out as you work through them that, oh, this is actually a really hard question. I need to save it for later. So let's say we look at a passage and it has 6 questions. And the first one, we realize it's going to be pretty easy. The second one looks pretty medium. The third question just looks super duper difficult. It's got 6 or 7 lines of text, and it's got massive answer choices, and it's got all these numbers mixed in. It's just going to be a really hard question. But question 4 looks really easy and friendly. Question 5 looks pretty medium, and actually question 6 has almost no text and just some numbers. It's really easy looking. If that's the case, then maybe we should be attempting the puzzle in this order instead, where we do question 1 and then 4 and then 6, and then try 2 and 5 and save 3 for last. That's the path of less resistance. It's as if you were working your way up a mountain. It just doesn't make sense to try the question that's at the top of the mountain first. Work your way through. And interestingly enough, a lot of the time on the science, the questions build off of one another. So if you do question 4, it might give you a hint for question 6 or for question 2 that you would not have gotten had you tried to do, say, question 5 first. Or had you tried to go in order because 4 would come after 2. The idea is that when you take a look at your passage or when you take a look at your puzzle, there's an easier or a harder way to put it together. The easiest way to put a puzzle together would be to line up all the flat pieces, put the corners in the right spots, and then try to work your way in. We want to do the same kind of thing with an ACT Science section. So that's the path of less resistance. Here's a real example for the PLR. If you'd like, you can take a look at the Science 2009-04 PDF. This is passage 4, so I've just taken all of the information from the passage and I've posted it on the slide so everybody can see it. There's quite a bit of information. What you don't want to do is read all this information. That would take quite a long time, and you would get a lot of extra information in your mind that really wouldn't be that helpful. Here are the questions for the passage. So the questions go from 17 to 22. And actually, before we get to the PLR, let me just talk timing for a moment. This passage, passage 4, has a last question that's question number 22. So the last question is question 22, and the passage number is passage 4. That means that you should be done with this passage by 18 minutes. So it's a running time. And I just want to reiterate that. Maybe passage 5, the last question is question number 28. So then 28 minus 5 would be 23. You should be through passage 5 by 23 minutes, etc., etc. If you guys have questions about the timing, I can talk about it at the end. So just feel free to type that in. Back to the PLR. If we look at passage 4, 17 looks kind of medium. 18 has these numbers. When you've got numbers in columns, that's easy. 19 also has a lot of numbers. In fact, it has formulas. That's probably easy. 20 might be friendly. 20 is going to turn out to be really difficult, but we're not going to know that until we actually get into number 20. So 20 is one of those ones that looks friendly, but it's actually super duper difficult. It's probably one of the hardest questions on the test, even though it's only number 20 out of 40. And in fact, the ACT does that a lot. Sometimes the hardest questions, in fact, very often the hardest questions, are in passage 4 or 5 instead of passage 6. So keep that in mind. They put questions in the middle to try to waste your time. It's okay to save for later a question like number 20 when you get stuck on it. 21 has some text. It's more medium. 22 is one that looks easy, but it turns out to be more medium. So the PLR, the best way to go through this would actually be to go from 18 to 19 or 17, because those are both kind of medium/easy. Yeah, that's right. And then go to 21, and then 22, and then 20 you would actually have to come back around to. Now, most test takers are probably going to try 20 and have to give up on it. So they would have tried 20, but then they would have realized it was too high up the mountain, and they would have had to save it for the end, and they would give it a try then. So that's how the path of less resistance works in this passage. Another interesting point to give, and you guys can practice this because now you have the science section, question 19 actually gives you a hint for question 22. And what's interesting is that if you solve 19 and then 22, you'll probably have enough information to be able to answer number 20. A lot of people find themselves getting stuck on 20, but after they finish the other questions in the passage, including number 22, they get a good shot on number 20 because 22 gives a hint that points back to 20. The questions on the ACT Science are not designed to be done in order. I cannot stress that enough. It's like a jumbled puzzle that's been shaken up in a box. So what you have to do is reorganize the question in your, or the passage in your mind, and go through the questions in the order that looks easiest to you, being aware that sometimes a question is actually more difficult than you thought, so you have to save it for later. That's how you're going to have to go through, especially on a tougher passage like a passage 4 or 5. Passage 1 or 2 might not be so difficult. You might be able to go through in order. But even passage 1 and 2 have a personal order of difficulty or a path of less resistance. So how do we know our path of less resistance? Well, as I kind of already said, there's definitely the save for later going on. And in fact, there are 2 types of save for later, and we'll talk about them. And the other thing is the CALI-V, which I already briefly mentioned, but I'm going to go a lot more heavily into and explain how this acronym is a life-saving, or at least a time-saving apparatus that we can use on the test. So save for later. S4L1 means save for later, which means you're saving within the same passage, just like number 22 that we were talking about in passage 4 above. When we were looking at number 22 and we got stuck on it, we said, this is really challenging. I feel like I'm in a spin cycle, like I'm in the washing machine. I just can't get out of it. When you get that feeling of anxiety or being stuck inside the question and you notice that it's been over a minute, just save the question for later. You can always come back to that question, especially after you finish the other questions in the passage. Sometimes the other questions will give a hint. Expect to do the save for later 5 to 8 times per test, and usually on later passages like 3, 4, 5, or even 6. Well, especially passage 6, because you'll be a little rushed on passage 6 at the end of the test. Depending on how strong you are at science, you might only save for later 2 or 3 times, but every student is going to save for later. So I really would say it's around 5 to 8 times for the average student. The other type of save for later is a save for last. So after you save for later a question and you come back to it in the same passage, you still might be stuck. And that's okay. Some of the hardest questions on the science show up earlier on. I would like to reiterate that. So I'm going to come back to the face and just say, okay, the way they design these tests is to overwhelm you. And I don't know if you guys have heard this before. A lot of people think when they're taking an SAT or ACT, the test is supposed to make them feel good. They're supposed to feel confident as they go through. It's supposed to be this kind of rewarding experience that reflects how good they are as students. That's not often the case. A lot of people who are really good students, a lot of people who get straight A's or A's and B's, end up with scores that don't reflect how good of a student they are. And that's because the test is designed to trick you, and it's also designed to overwhelm you. What the SAT and ACT are testing is something more akin to the type of intelligence that would be useful on a military battlefield or perhaps in an executive boardroom. It's the kind of thinking that you have to do very quickly. It might also be the kind of thinking that maybe a trial lawyer or a doctor or somebody who has to think really hard under a lot of pressure has to do. It's not the kind of thinking that would be typical to be used by a teacher or an artist or an engineer or a researcher or just about any other person on the planet other than those really high profile, high pressure kind of vocations. Why the test teaches or tests this kind of pressure thing, I'm not sure. I think it has something to do with the culture that we have. It's just something to do with America. The tests have been around for about 100 years, so they have this kind of history to them. But what you'll find when you take an ACT science section is that it's not really so much about how smart you are in science. You just have to have a basic level of science understanding. What the test is more like is it's like a video game. And what it's going to try to do is throw tricks at you, and you have to figure out how to maneuver around those tricks or let them go or go find the bonus shortcut or just come back around and challenge it later on. The test is more about your timing awareness. It's not so much about how good you are in science, and it's really not so much about how careful a reader you are or how good of a student you are. It's about reading quickly. It's about making snap decisions. It's about crossing off. And it's the kind of thing that you have to practice. You have to practice it over and over again. It's like a skill. Like I was saying last week, if I wanted to get good at swinging a golf club or something like that, then I would have to take a golf club and I would have to practice swinging it over and over many, many times, probably for many, many days, probably for months. But you don't really have to practice ACT science necessarily for months. Um, and eventually I would get better at swinging a golf club, and then I would be able to knock the ball a lot farther than I could ever throw it. So by the same analogy, once you get used to using the PLR and the POE on the science, you'll find yourself moving a lot more quickly through the test. But it's going to take like 5 or 10 practice science sections. It's not the kind of thing that just quickly drops into place. If you wanted to get really good at a video game, it's going to take more than 2 or 3 tries at the video game to get good at it. A good way to think about it is like a video game or a sport. It's something you have to master. So I just really want to make that point to you guys. People get better at this. I see it all the time. But it's the kind of thing that takes a little while, and it takes consistent, collaborative, and reflective engagement with the material. So coming back around to our slides. Again, you can save for later the first time, or you can save for last once you realize that the question is just not a question that you want to do. Sometimes question number 20, sometimes question number 11. In fact, a lot of the time, question number 11 is one of the hardest questions on the science section. Why do they do that? Because they want to waste your time and not give you enough time to finish at the end. Some of the easier questions tend to be in the last passage. The test does that to reward you for finishing. It's not rewarding you for your science knowledge, it's rewarding you for your time awareness knowledge. So I would say for a 26, you can expect 4 to 6 saved for lasts. Like, let go of around 4 questions. Just take your best shot, but don't worry about them. That can be a really challenging thing for some students. Some students think they have to answer every single question. I'm afraid you can't do that on this test. Part of becoming better on the ACT science is knowing how to let go of a question or two. Arguably, the same technique holds for the entire test. So in the English, the reading, and the math, you kind of have to know how to let go of some questions so you can get to the end. A realistic goal is to try to get 5 out of 6 on each passage, or 6 out of 7, depending on if it's a 6 or 7 question passage. Just think that if you can get -1 on a passage, you're actually doing really well. And you just want to keep moving and not worry about that one that you missed that you saved for last. Another way to say this, do the easy test first, use the PLR, and always practice with your timing watch so that you know how you're moving through each passage in time. It's really important. Okay, so the next most important skill, and this is, I'm sorry there are so many acronyms, but this is just the best way to learn it. CALI-V is the acronym that I've come up with after years of working with many students. CALI-V is the sequence that we use to go through the passages. It's kind of like the PEMDAS, like the order of operations that you would use for the science as opposed to the math. Part of recognizing the path of less resistance involves knowing how to solve the easy questions first. So we need to be able to identify the easy questions, and we need to be able to use the least amount of information to solve them. Think back to the puzzle in the box. What we did with the puzzle in the box was first look at the corners, line them up, then we lined up the sides and connected them, and then we would look for similar shapes in the center, like a moon or whatever there is that happens to be a cluster around some sort of drawing or shape that's in the puzzle. We can use the same kind of thinking when we look at the questions on the ACT science. So the C and the A, they go together, just like the M and the D in PEMDAS, right? Multiply and divide. So C and A, these are on the same level as each other. The C stands for looking at charts and graphs. The A stands for looking at the answers. When you look at the charts and graphs and you look at the answers, you can often find the right answer without reading any text other than what's in the charts and the graphs. I would say that C and A holds for about 35 to 45% of the questions on the test. So I want to say that like PEMDAS, always, always, always check the charts and graphs and then the answers first, because you would always, always, always do the parentheses and the exponents first if you were solving an equation. So here's a chart and a graph. I'm not sure where, oh yeah, this is from, I think, passage 4 actually in the same test. And what we're looking at are 3 columns, and we've got a bunch of numbers. What's really helpful to do is to make trend lines when you're looking at a chart or a graph. These numbers are increasing as we go down. These numbers are increasing as we go up. These numbers are increasing as we go up. Making marks like these can help us to lock in and see the trend or the pattern in the questions. We also want to pay attention to variables. So the volume of heptane or of isooctane or the octane number, those are all variables that tell us what's going on in the experiment or in the chart or graph passage. We always want to take a look at the variables and the number patterns, aka trends, and we always want to look at the keys to the charts or graphs. If the chart or graph has a key, then you can bet that it's going to be important. So here's another chart or graph. I think this is from the first passage on the 2009-04 packet. And it has a y-axis, it has an x-axis, and it's got some bar chart things with some numbers. And super important, it has a key. And you can bet they're going to ask questions about the key. So one way that you can think about looking at charts and graphs is by playing the flute. This is the instrument that you can use. Just turned out to be a flute. It's kind of funny that it is a flute, but it's a flute. This is kind of like the flood step in the math. First, you always look at the figure. It'll say if it's figure 1 or figure 2, or it'll say if it's table 1 or table 2. But that's the same thing as the figure. Then you take a look at the label, whatever the labels are. In this case, the labels are the days and the E. coli colonies. So those are what matter. Those are the variables or the labels for the chart. And we would also take a look at the site 1 and site 2 because those are other labels that matter. The units are going to be really important. And then we can notice trends, and sometimes we can extend the trends. We're not actually going to extend the trends in this lecture today, but we will talk about identifying trends. So the flute is useful when we're doing the C and the A, the CA part of Cali B. Here's an example using the C and the A of Cali B. And this is passage 1. So if you guys would like, you can take a look at passage 1 in your 2009-04 PDF that you have hopefully downloaded. So it has the same figure that we looked at. There's also a second figure. And question 1 says, if an E. coli level of over 400 colonies formed per 100 milliliter of water is unsafe for swimming, on which of the following collection days and at which site would it have been unsafe to swim? Now that's a lot of information. I think most people, when they read this, their brains just kind of glaze over. So if you found yourself reading this and going, what the heck did I just read? That's absolutely fine. Because all that you need to be doing is paying attention to the E. coli level, and apparently of over 400. So E. coli over 400, and then you're trying to figure out unsafe to swim. A lot of the time to solve a question, what you need to do is break it down in your mind. This question is focusing on E. coli level of 400. I wouldn't worry so much about the 100 milliliters of water, although it turns out that the 100 milliliters of water is actually reciprocated over here. So we're probably going to be looking at figure 1. And I've kind of done all the markings for you guys here. But these are the kind of markings that you would want to make in the passage as you are figuring out the question. It's totally okay to circle. I encourage circling. I know it sounds weird. It probably sounds really weird. But circling a variable locks it into your mind for at least 30 seconds to a minute. And that can be really useful on the tougher questions that have 4 or 5 different variables that are being linked together. So it's actually really useful to circle the things. And this is what I teach my students to do when they go through science. And by the way, they really hate circling, but they end up using it quite a bit and they end up improving. So circling is good. We're also marking at the 400 line because they said that anything over 400 is bad. So if we mark the 400 line for E. coli colonies per 100 milliliters, we notice that this bar chart with the 708 is standing up and nothing else is. So this must be the answer. We really don't know what it means. We just know that this bar chart that has a 708 on top is the answer because it's above 400. And what the bar chart corresponds to is site 1, according to the key. And when we look at the days, apparently it's day 30. Oh, so that's the answer. If you're not sure that you have the right answer, you can always cross off another answer or two just to make sure that you are correct. I strongly recommend that students take 5 seconds to cross off another answer, even when they found what they're 99% sure is the right answer. I wouldn't take more than 5 seconds, but it's just a nice way to make sure you're sure. Here's another question from the same passage. So this is question 2 from passage 1 in the 2009-04 PDF. Based on figures 1 and 2, consider the average water flow and the average E. coli level for site 1 and site 2 over the collection period. Blah, 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 blah. That was a heck of a lot of words. If we were reading through, probably what we'd want to do is circle figures 1 and 2 and circle E. coli level for site 1 and site 2. Those are the details that are going to matter. Then they ask the question, which site had the higher average water flow and which site had the higher average E. coli level? Oh, so this is like a POE question like we saw earlier where we've got one column and then another. If we wanted to, we could just focus on this one column first, the one with higher water flow. And so what we ask ourselves is, which one has, or where do they talk about higher water flow? And hopefully everyone noticed that water flow is in figure 2. It's the variable on the y-axis. And it turns out that in figure 2, the ones that have higher water flow are all site 1. So all of the bars that are site 1 have higher water flow. So site 2 cannot be the answer for the higher water flow component of the questions. So that means H and J are gone. We've used POE, and now we make a choice about F or G based on the E. coli level. What we're doing is we're moving one thing at a time. And I made this point earlier, and I just want to say it again. Don't try to do everything at once. Hopefully you guys can see that we're moving through one piece at a time. We're not trying to juggle 5 things in our minds all at once, because that can be overwhelming. It's really difficult to juggle 5 things at once and make it all the way through the science test after doing 3 hours of other testing. The correct answer is F. If you chose F, well done. And let's move on to another solving with the charts and the answers. So let me back up just a second. Notice that we did not read any of the text. There actually is text in this passage. I did not copy and paste the text because it's not relevant to the question. Neither question 1 nor question 2 needed any text. All that we needed was the charts and graphs and the answers, and of course we had to read the question. We're going to do the same thing with question number 3, although this question has a little bit more thinking and emphasizes a little bit more annotating. So I'll talk about how to do the annotating. This is from the same passage, and it refers to table, I think table 2, although that's also going to refer to table 1. So I pasted table 1 and 2 in. However, I want to point out that table 1 and 2 are part of an array of tables and figures that together constitute passage 1, which you can see if you take a look at the 2009-04 PDF. Okay, so question 3 says, as water quality improves, the number of stonefly larvae increases. That's a lot to try to remember. So if we were good test-taking students, what we would do is annotate that. As WQ goes up, SF goes up. That's just a good thing to store in our little storage box over here so that we can then focus on other parts of the question and come back to this if we need it. So we're just going to write that down and store it. I cannot stress enough how important it is to save information on the page. I think I talked about this quite a bit last time we met when we were talking about math fundamentals and using the flood step to mark the diagrams or write down the formulas. It's the exact same idea when we work through the science. Students hypothesized that more stonefly larvae would be found at site 1 than at site 2. Okay, we can write that down as well. Site 1 should be greater than site 2. Are the data presented in table 2 consistent with this hypothesis? We're kind of stuck here though. Like when we look at table 2, it just says site 1, site 2, and it says average BI. So if we only looked at table 2, which is what the question is telling us to do, we would be stuck. However, when we look at the answers, we notice that the answers talk about site 2, quality, and they talk about BI. Oh, so the BI is in table 1. And apparently if the BI is above 3.6, then that means the water quality rating is excellent. So BI, whatever that is telling us about the water quality rating. And so if BI is low, then there's poor water quality. And if it's higher, then it's excellent or good water quality. So if we look at site 1 has a water quality of 6.3. So site 1 has high water quality. So if we go back to what we annotated, which by now we might have forgotten, but thankfully we annotated it, yeah, that works. Site 1 is greater than site 2. Okay. So that means that we can get rid of C and D because we're saying that, yes, the site 1 is greater than site 2. Why is site 1 greater than site 2? Because the water quality is greater, and the water quality is linked to the stoneflies. Let me restate that because that might have been confusing. Students hypothesized that more stonefly larvae would be found at site 1 than site 2. More stonefly larvae means higher water quality, which means it should be higher water quality at site 1 than site 2. Well, when we take a look at table 2, we notice that it is higher water quality at site 1 than site 2. Therefore, C and D are the wrong answers. Don't worry about answering the question all at once. Worry about crossing off the 2 answers. Then you can select whether it's A or B. It turns out that the selection between A and B is easy. Site 1 has a water quality rating of good, and B says that site 1 has a water quality rating of excellent. Well, site 1 is 6.3. That's a rating of excellent, not good. So it should be B, not A. Notice again that we're just thinking through one thing at a time. We're not trying to juggle everything at once. When we have multiple things in our mind, we're saving them on the page. This is probably the best way to practice And I strongly recommend it as the best way to test. These aren't really training wheels. These are ways to think, and you can use them to get through stressful situations. The second stage of Cali-V is L plus I. L plus I means referring to the lab text or the intro. So in the second stage, we'll go hunting and we'll go read. And we'll read because we're stuck, and merely using the charts and graphs of the answers is not giving us enough information. Once again, if the answers aren't in the charts and graphs, it's time to take a look at the lab text or the intro. And I want to note, you don't have to read everything. It's actually really not a good idea to read everything on the ACT Science. The only passage that you should read everything on is the one that is all text, called The Fighting Scientists. I haven't given an example of Fighting Scientists here, but you'll know it when you see it because it just has a lot of text. And you actually do have to read all of that like a reading passage. So for 5 out of the 6 passages, we're not going to read everything. We can scan for keywords, and we should pay attention to the italics. Here's an example of solving with L plus I. This is passage 2 of the same overall science section. Passage 2 has a table. Looks like it's got days and AWP, whatever that means. And then there's also a figure, and the figure has a key, and it gives you these different lines for EDTA and gluconic acid and other things that we don't know how to pronounce, perhaps. Maybe that's cupferin. I don't know what that is. It's kind of fun to make fun of the names, and what I'm trying to do by making fun of the names is show that you don't have to know them. You just have to match things. You don't have to understand everything that's going on. You just have to try to match and then read when you get stuck. So question number 9 in this passage says, in the trials represented by Table 1 and Figure 1, by measuring the volume of H2, the experimenters were able to monitor the rate at which. Okay, so they said that we should look at Table 1 and Figure 1. So let's take a look at Table 1. Yeah, there's volume of H2 and something about H2s and the days. And if we look at Figure 1, there's more volume of H2 and there's more days. But when we look at the answers, there's nothing in Figure 1 or Table 1 that has anything to do with what is shown in Table 1 and Figure 1. Let me repeat that. When we look at the answers, none of these symbols seem to be matched by Table 1 or Figure 1. So we're stuck on C and A. Well, that's okay because these symbols that are in the answers, they're kind of over here in the intro. And in fact, if we look at the intro, it turns out that this is the key equation that's being explained by, I guess, Table 1 and Figure 1. And even though whether it's linked to Table 1 and Figure 1 is irrelevant, what I'm trying to do is cut all these ties by talking about them, because I know that a lot of people start thinking over to all these other things. The goal is not to try to connect everything in your mind. The goal is to look at one thing at a time. When we look at the one thing, what's in the intro, we're given an equation, and that equation is enough to find the answer. When we look at the equation, we're certainly not talking about how H2O is converted to Al, because H2O is not converting to Al. H2O and Al are on the same side. And we're not talking about Al being converted to H2O, because that's the same thing as A, but reversed. So we can cross off these 2 easy answers, and then we can choose whether it's C or D. If you were going to bet $100 on one answer, would you rather say it's Al converted to AlOH3, or would you like to say AlOH3 converted to Al? Well, the arrow is going left to right. So probably, just taking a guess, if we're not sure, it's probably going to be C because the arrow goes that way. And of course, if you know your chemistry, then you would be able to choose C outright. But I want to show that you don't even have to have really strong knowledge to be able to answer some of these questions if you're using POE. The correct answer is C. So that's how we use the intro, because we were stuck on the charts and graphs and the answers. We used the lab/intro. Actually, we used the intro. Here's one where we'll use the lab. I think this is from passage 3, again of the same science section. So we have a study. We've got all these scales and weights on the scales. And then we have another study. And then we've got scales and apparently a board and some pencils. And question number 16 asked us, which of the following statements most likely describes an important reason for setting the dial reading of both scales to 0 after study 1 prior to each of trials 4 to 6? A lot of us, when reading that, would decide that, wow, that's a pretty medium level question. So probably we would do some other questions first. But once we've done those other questions, then we can come back and we'll take a look at what 16 says, and we'll say, when we look at study 1, we don't really see anything in this figure that corresponds to what they're talking about, which is resetting the scale. And they don't talk about in any of the other figures as well. And when we take a look at the answers, we really don't see anything very helpful. So what that means is we're going to need to read. So we're going to have to read study 1, and then we're going to have to see if we can find any words that match. So when we read study 1, we do find some words that match. Apparently, before trials 1 to 3, the students set the dial readings of both scales A and B to 0. They actually did the same thing in study 2. Prior to trials 4 to 6, they set the dial readings of scales A and B to 0. Well, if they set the dials of A and B to 0, then they were probably not adding the weights of the board and the pencils or of the scales. So if we're just using common sense, we can cross off F and G. That's super helpful. Because now we're looking at H and J and we're saying, are we subtracting the weights of the scales? Or are we subtracting the weights of the board and the pencils? Well, it turns out, and I didn't explain this very well, but trial 1, 2, and 3 are study 1. So trials 4 through 6 are study 2. 4 through 6 have boards and pencils. So the correct answer is J. And what I really want to stress again, for the third time I think, is that we're moving piece by piece and we're not trying to solve the whole thing at once. Trying to solve the whole thing at once is going to be a bit of an anxiety trap. What we want to do is go through piece by piece because that's how we're going to get through. The last thing that we've got is solving with V. V stands for visualize. So Cali V, the last thing, kind of the home run hitter that you have is visualize. And that's what you're going to use if you get stuck and you're going to use your common sense to take your best shot. You do this last because it's the slowest. It involves trying to understand kind of the whole passage at once, but it also involves using common sense. It's not trying to use really high-level AP thought. What you're trying to do is just give your basic understanding that you would have had if you were taking this as an 8th grade student. Believe it or not, your 8th grade common sense is sufficient to answer 95% of the questions, if not 99% of the questions on the ACT Science. You should expect to use the V in Cali V about 3 to 6 times per test. And these questions tend to be the most anxiety producing for students. That's why you want to do them last. You're going to S for L them, you're going to save for later, and you're going to give them your best shot when you come around at the end of the passage. So let's go through an example. I'm going to give you guys a moment to take a look. This is passage 6. We've got all this information. Here's a question from passage 6. So we would have done other questions before we get to 31, but 31 says, during osmosis, water migrates through a semi-permeable barrier. The osmosis referred to in the passage occurs through which of the following structures? And if you were to read through the tables, there's nothing talking about osmosis. And when we look at the experiments, just scanning, there's nothing about osmosis. When we look at the answers and we look at chromosomes or nuclear envelope or cell membrane, none of these things are in the passage as far as we can tell. Even when we look at the intro, there's really nothing. So a person who hits this question might really start to freak out because they've been doing a lot of matching and catching answers and looking at the charts and graphs and linking up the variables to what's mentioned. Just a lot of information processing has been going on, and then all of a sudden you get this question that's kind of the last thing that you expected. Well, the question is just common sense. When they're talking about osmosis, which of the following answers has a semi-permeable barrier? Probably not chromosomes. And, I might have crossed off the right answer. What I meant to cross off was D, so I apologize, there's a mistake there. Probably not the rough endoplasmic reticulum either, whatever that is. So you should at least be able to cross off A. It does turn out that there's a hint later on in the passage, or earlier in the passage, because they do talk about, the word osmosis in the beginning of the passage. So there's kind of a LI, a lab intro moment here. And they say that a net movement of H2O between the cytoplasm of the plant cells and the environment is via osmosis. So what that means is that there's some sort of a movement that's going between the cell itself and the outside environment. And I don't know why I circled rough endoplasmic reticulum, probably because I have a toddler. But the correct answer is actually the cell membrane. So if you were worried about it being D, it's not. You can cross your way through and your best shot would be cell membrane. But notice that they don't really give the right hint even by looking at the intro. This is kind of a common sense POE question. Here's a better example, and this is from passage 1. So there's actually a V for visualized question really in passage 1. Passage 1 was the one that we looked at earlier that had the site 1 and site 2 and the E. coli and the water flow and the water quality. And question number 5 in passage 1 says, suppose large amounts of fertilizer from adjacent fields begin to enter the river at site 1. The BI of this site will most likely change in which of the following ways? The BI will. Well, a lot of students, when they look at this question, again, just start to have this anxiety trap feeling because when they look at the tables, there's no mention of a river and there's no mention of fertilizer. And when they read the passage, there's no mention of fertilizer. And a lot of people find this really, really stressful. Well, you shouldn't find it stressful because it's actually something that you can handle. And here's what I want to say in this moment. When you feel the anxiety ratcheting up, and you will, the test is designed to create it. It's something that you just have to deal with, like in a video game. Take a deep breath. I really mean that. Just take a deep breath. Like, you have enough time to take a breath. There's nothing wrong with taking a moment. Because what you need to do is pull yourself away from that moment and sit for a second and think about it using your common sense instead of your test-taking brain. And when we think about this commonsensically, what does fertilizer do to water quality? Answer it how you would as if you're an 8th grade science student, not as if you're an AP test taker. An AP test taker is going to think all sorts of things about the fertilizer that probably have nothing to do with the question. I also want to remind before I give the answer that you can always use S for L1 and S for L2 on these questions. In fact, you should have used S for L1 and saved it for later. And you can still use save for last if after you take a breath, it still isn't making any sense. That's totally fine. There's nothing wrong with letting go of a question, even number 5, because what you have to do is get to the end of the test where some of those bonus questions are that are easier to finish. So I just want to iterate, do not spend more than a minute on any science question. Use save for later. And it's always okay to take a breath. And don't forget using common sense. The common sense answer is that when you add fertilizer, the water quality is going to go down. That's outside knowledge. You just have to know that. And really, when you think about it, everyone notices or knows that. Fertilizer is going to make water quality down. Now, I've seen people look at this question, and then they read about E. coli, and then they think about fertilizer increasing E. coli, and then they think that E. coli has something to do with water quality rating going up, and they somehow reverse the entire question. That's thinking the AP way. That's thinking the wrong way. That's trying to think with anxiety and trying to think all at once. What you have to do is take a deep breath and think with your common sense 8th grade mind. Don't think about this as if it's a really difficult, challenging AP question. It is not. This is a standardized test question, and it's designed to produce anxiety. So water quality is going to go down. So if water quality goes down, we already know from table 1 that BI is going to go down. So it's not A or B because that says BI increase. And then we take a look at C and D, and very clearly it's going to be D because water quality is going to go down. Again, POE first, then make your selection between the 2 questions. All right, so let's recap, and then we'll open up for questions. So this was a lot at once, and if you found this moving along pretty quickly, I strongly recommend that you go through the slides again or even listen to the lecture again. I just gave you guys an entire arsenal of techniques, but these are techniques that you need to practice and that you need to work on, again, 5 to 10 passages, not like 2 or 3, like 5 to 10, before you start to get the hang of some of these techniques. Timing is really important. Remember that there's a running timing where you can take a look at the last question of the passage and subtract the passage number, and then you can use that to figure out where you should be finishing the passage. So if it's passage number 6 and the last question is 33, then you should be finishing passage 6 by the 29th minute. Although passage 6 is usually the last passage now. Sorry, it used to be the second to last passage. POE means process of elimination. You saw that demonstrated many times as we went through the questions today. Always try to cross off 2. If you can cross off 2, you're going to be in a really good spot to make it through the answers. PLR means the path of less resistance. We saw that today as well. When you get to a passage, take a look at the questions and assess them. Questions that have more numbers and have fewer text are probably going to be easier. You can also organize questions by the order of experiments. So if it talks about experiment 1, you might want to try to do that question first, then do the questions about experiment 2, and then the questions about experiment 3. Also Cali-V, which we've talked about, which is your order of operations for how to go through questions. First look at questions first look at the charts and answers, especially for questions that have numbers in the answers. Then take a look at the lab and the intro if you get stuck and try to figure out that key term. For example, the key term that we saw that was useful in one question was the word osmosis. Another key term that was useful was a phrase was setting the scale to 0. And then if you get stuck, save for later. And when you come back to the question, visualize. Cali V is your order of operations. I recommend that you write it down. I recommend that you think about it and that you reflect on it and that you practice it. The other thing that we talked about is save for later, which is built into Cali V. And it's also built into your personal order of difficulty, and it's also built into your timing. So the science section is a challenging section. It's as challenging as you might find the reading to be. And in fact, a lot of these techniques that we talked about in the science are also applicable to the reading, in that you can organize the passage before you go into it, and you can always use save for later. And if you're stuck, then let the question go. You can always process of eliminate and cross off answers. The more that you can whittle down what you're thinking about and just focus on the things in front of you and do them step by step and use the paper to save your information, the more efficient you're going to be, the less anxious you're going to be, the more confident you'll feel, the better test taking experience you're going to have. But again, it's something you have to master. It's not something that's just going to happen right away. It's something you have to practice. And again, it's something that anybody can do. It's not the kind of thing that only a certain type of person can do. Just about anyone can learn how to do this, just like just about anyone can learn how to swing a golf club or to kick a soccer ball or to get good at a video game. So moving back to the end of our little lecture, some parting suggestions. If you've taken a practice test, then you know how much more work you need to do. And the good news is that everybody's going to go up with the right kind of practice. And the right kind of practice, and I said this last time, is to be consistent. You need to make sure that you go through and do this stuff 4 times a week, and maybe a test as well. At a bare minimum, 3 times a week. You should be sitting down for 40 minutes to 60 minutes at a time, at least 3 times a week, going through this. If you're only going once or so, maybe twice a week and looking at these passages, it's not likely that you're going to improve. That's just because there's too many other distractions in between your practices. You have to do this consistently. Probably one of the best times to practice is near the end of the day when you're tired. But that's also one of the hardest times to actually pull out the test and practice. So you might be best served as soon as you get home from school, just getting it out of the way and then working on other things. If you have a free period, that's not a bad time. And often other students will want to talk with you about, oh, is that an ACT section? Or is that an SAT section? What are you doing? And what kind of questions are tough? And that leads to the third part, which is collaborate. It's really good to share this with people. People learn together in groups. You're going to find solutions from other people that you didn't expect. And in teaching things to other students, you yourself will get a lot better. And that dovetails with the second point, which I guess is my third point, which is to reflect. When you do a section, go back over it. Figure out why you missed it. Figure out how you could have gotten the right answer, or whether you should have just let that question go. You have to really spend almost 15 minutes for a 35-minute passage, reflecting on it, processing it, trying to figure out which questions you could have gotten back, maybe saving questions and asking them to your friends or other teachers so that you can understand why you missed it and how you can do it better. This is the learning process that you have to engage in order to do better on this test. Okay, so I'm going to open up for questions. It's a little bit early, but I think we'll have quite a few. The science is a pretty technical section, so I look forward to whatever your questions. And if you have other questions besides, you're welcome to email me, or you're welcome to email Anthony. We're happy to give. I'm not going to be able to give you answers to specific questions on your test, but I can point you in directions where there are resources, and I'm happy to help in whatever way I can.
All right, everybody. Once we have some of the questions come in, thanks, Travis. Cali V. Cali V.
Cali V and flood step. That's just wearing it up. I'll be right back. Sorry.
Yeah, no problem. So, guys, once you have the questions come on in, as we kind of wrap up, and we'll try to get Travis's answers to those, and we'll finish our boot camp here. A lot of good stuff tonight. Again, all this stuff we've been going over the last month. I mean, we could spend hours upon hours. It just, unfortunately, I wish we had the time to do that with you guys. But it's again, is meant to get your feet wet, start you thinking about what things you can do and implement, and try some of these new strategies and methods that we've been teaching you. A lot of good stuff. All right. how do I access the recordings? Guys, I showed you at the start of this, you have a link that I've been emailing you and anyone who has signed up for the test. There is a link that takes you to the student folder, and that's how you access the recordings. So go check your email, and it should have anything that I've sent you about this boot camp over the last few weeks has a link. I sent one just last week. I'm going to send another one after tonight to everybody who's attended or signed up. It's going to remind you where that link is, so make sure you check your email. That had nothing to do with the science, but still always important.
Yeah, I mean, just any questions about timing, or if you're looking at that 2009-04 packet, if you guys have any questions there, I have a copy and I can go through, can even demonstrate some of it. That's fine as well. So
I got a private question there that was, and just one that's come up as well. So I think it's applicable. You know, some people might be taking the SAT. So there's no science on the SAT in terms of a particular section. But is there science on the SAT? Just to kind of clarify that for everybody.
that's on me.
Yeah.
Yeah. So I mentioned this in the beginning. There is a science section of the SAT, but it's not actually a section. It's a whole bunch of questions that are interspersed throughout the test, and then they become part of the Common Core score of the SAT in your science. So they have charts and graphs actually blended into your grammar section and into your reading section, and also to some extent in your math section. And it's 2 or 3 questions per chart or graph, and they're very similar questions to what you would see on the ACT Science, although they're not quite as focused because they're not 6 or 7 questions at once. They're just 1 or 2 or 3 based on a chart or a graph.
And you'll see that if you guys have taken the PSAT and you actually go into your score report online, you'll have a sub-score of science, and you can actually find those questions if you were curious. Anything else, guys? Or Travis did such a bang-up job, you get it, you know what to do.
I'm worried that I talk too fast and scared people.
Oh, you're scared. It's like, maybe they're switching away from the ACT. That's what you did, Travis.
Yeah, but
I think I want the SAT now.
Hey, try them both. See what you're better at. That's
yeah, and everybody, if you've, I know some of you are scheduled already, but we do have a practice test, or any of the ones that you saw the links on. You can take one, ACT or an SAT, but if you have a PSAT, you can compare your score, see which one you're better suited for before doing it for real, and then choose that one path. I mean, if we have no questions, we'll give Travis a break and we'll end early for him.
I can take 5 minutes and just demonstrate a passage. Happy to do that, if that would be helpful.
Folks, if you say yes, chat that in if you'd like Travis to do that, if you want to stay on and have him demonstrate it, and then we could do that. Anna says, yes, please do that. And then somebody anonymous says, where's a good place for me to find some practice questions in the science section? Well, again, I sent you in your student folder, there's links to a bunch of practice tests. You have, 4 to 5 practice tests. You can also buy a book in a bookstore. Travis, anywhere else you recommend for some good science?
Yeah, I've tried a number of the books. I would say the best book out there that I've experienced is the Princeton Review Cracking book, or the Princeton Review 1460 ACT book. They're not that expensive. They're like $15 online, or you can probably get it from your library and just not make markings in it, although that's not a great idea. You actually want to spend the $15 and get the book. The reason that I like that book is because it will give you good explanations, and the science sections are fairly realistic. Another great place to get science sections is by going onto the ACT website and downloading the practice science or the practice tests, which have science sections in them. The only problem is that those tests don't have explanations, so you're going to have to work with other people and try to figure out why you're missing some of the questions. That can be a little bit more challenging, but if you use CaliV and you take your time, you'll probably find yourself getting quite a few right and surprising yourself, especially with POE.
I went to my bookshelf. I grabbed a couple books, guys. You got the ACT guide, which is for the real ACT from ACT. But like I said, if you go to the links that I sent you, you can find practice tests. Travis mentioned Princeton Review.
This is a good book. It's not that I'm affiliated. It's just a good book. I've used McGraw-Hill. I've used Barron's. I've used Kaplan. I find this to be a good book because it has explanations in the back. Each test has full explanations, and that's fairly useful. There are other books. You can take a look online. You want something that has realistic-looking science sections. You can tell if they're realistic-looking because you can compare them to the real tests that you downloaded.
Yeah, here's another one, ACT Elite. It's some same company that Travis has right there. So between those books you find, as well as the practice tests that I gave you links to in your student folder, that should be plenty of practice.
Yeah. So let me take 5 minutes and demonstrate a section. I'll just demonstrate passage 1 because that's the passage that we focused on already. So here we've got the same passage, or the same section that we downloaded, hopefully, and everybody can see the passage. And this is the passage that has the site 1, site 2, and it's got the E. coli colonies and the water flow and all that. So I'm just going to work through it and make some of the marks and just show you how a person would think if they were taking the test for real. So the first thing that you do is you can scan over the passage, and you can take a look at this, that, this. And you would also take a look at table 1 and also notice the variables. You don't have to circle these things necessarily, but these are the things that you would focus on in the beginning. Notice that we're not reading the text to start. We're taking a look at just the graphs and the charts, and then we're going to take a look at question number 1. Although question number 1 has a lot of text, so maybe just with personal order difficulty or PLR, we could start with question 2. So let me redo question 2, even though we already saw it. Based on figures 1 and 2, consider the average water flow and the average E. coli level for site 1 and site 2 over the collection period. Which site had the higher, it's good to circle, average water flow, and which site had the higher average E. coli level? So we're looking for the higher one. And we're going to look in the higher water flow first. And when we scan over here and we try to figure out, well, where's water flow? Water flow is right here with figure 2. Okay, and the one that's higher is definitely site 1. That's a good thing to circle. We go back. Cross off site 2 because that has lower. And then which one has higher E. coli level? Well, that's probably going to be the other figure, figure 1. It looks like that's also site 1. So the correct answer would be F. You could actually do this question in about 20 seconds, but I'm talking our way through it so we can see it. Where to go next? Question 4 looks like it's not too bad. Let's take a look over there because it's got very little text. Which set of data best supports the claim that site 1 has lower water quality than site 2? Site 1 has lower water quality? I don't know. I don't see anything in particular when I look at the charts and graphs that tells me, well, actually there is a water quality thing here. So table 1. And table 1 says BI, and there's nothing about site 1 or site 2. So that could be rather confusing. Well, maybe if you're a really clever test taker, you'll see that there's a link between table 2 and table 1. But even there, I'm not quite so sure that we'd have enough information, and I'm not quite so sure we'd see the link. So let's just save for later right here. Number 4, we just saved. That's exactly how save for later feels. Couldn't find it. We were just spinning our tires. Wasn't going anywhere. That's fine. We'll come back to it in a moment. Let's try question number 1. That looks more medium level. If an E. coli level of over 400 formed per blah, blah, blah is unsafe for swimming, on which of the following collection days and at which site would it have been unsafe to swim? So unsafe is over 400 colonies. And E. coli colonies are not in figure 2. But they are over here. There's E. coli colonies. It's in figure 1. And we could say over 400, that's the mark that they were talking about. And so this column stands up above 400, and that's site 1. So the answer has to be something that has site 1. So it's not C or D. And oh yeah, it's day 30, so it's definitely B. Okay, so we've got 2 done, and maybe it's been about a minute and a half. Now we can go to, let's go to number 5. Number 5 looks kind of friendly. Suppose large amounts of fertilizer from adjacent fields begin to enter the river at site 1. The BI of this site will most likely change in which of the following ways? Fertilizer? So we're going to look over here, and I already explained this, but when we start reading, when we scan, when we look at the charts and graphs, and when we look at the figures, there's no mention of fertilizer anywhere. That's not good. So over here again, we got a question mark moment. We can look at the answers. Well, they talk about water quality. Okay, well, water quality is over here, but again, that has nothing to do with fertilizer. So we're stuck again, even when we look at the answers. And when we take a look at the lab and the intro, there's nothing about fertilizer over here. Biotic index, no fertilizer. Okay, this one is definitely saved for later. So we actually saved for later twice. Well, let's do number 3. Maybe that's not too bad. Okay, it's been about 2 minutes, maybe 2.5. As water quality improves, the number of stonefly larvae increases. Oh, we should save that. As water quality improves, the stonefly increases. Students hypothesize that the more stonefly larvae are going to be found at site 1 than site 2. So we want site 1 greater than site 2. Okay, we've got that saved, so we don't have to worry about it. Okay, I don't know where we're going to find. Oh, they talk about table 2. Okay, so table 2 is over here. Oh, so table 2 talks about BI, and BI talks about the water quality. Oh, that answers the puzzle that we had over here in question 4, where we weren't sure what to do because we're linking water quality to BI. That might be really helpful for question 4. It might not, but at least we made that connection now, simply because we did another question first. Okay, even so, does that explain that site 1 is greater than site 2? Well, site 1 BI is 6.3, and that means that site 1 has greater water quality. So the WQ is up for site 1, and that means that the stonefly are also up for site 1. So yes, site 1 is greater than site 2 in both WQ and SF. So it's not answer C or D. Yes, based on S1, site 1 had water quality rating of good. Well, is it? 6.3 is, no, that's excellent. It's not A. Oh yeah, there's the excellent. Water quality rating of excellent. Okay, B. So now we're at about 3.5 minutes. Now we go to 4 and 5. And by the way, it's okay if we don't get one of these. That's totally fine. Let's try 4 again. Which one best supports the claim that site 1 has lower quality? Site 1 is less than site 2. Well, table 2, as we just realized from doing number 3, shows that site 1 has higher water quality, because that's what we just solved with number 3. So it's definitely not table 2, nor is it table 1, because we just used those in number 3. So using POE and PLR, we just got rid of 2 answers, and now we're looking at figure 1 or figure 2. Well, which one has more about water quality? Well, site 1 has a lot of water flow, and site 1 also has a lot of E. coli colonies. Which one better shows that we have lower water quality? Just using common sense. Site 1 with the E. coli, or site 1 with the water flow? Well, I think common sense in my mind, and let me just flip back, just using common sense, if it's got more water flow, it's probably got better water quality. I mean, right, if it's flowing, then it's probably better. And I mean, between the two, I would definitely take the one with more E. coli as being worse water quality. Notice that I'm not reading the whole passage. I'm not thinking about all the other possibilities. All that I'm doing is looking at the information that I have, which is what's given to me by the answers. The answers say that we can only use figure 1 or figure 2. Okay, well, if it's a choice between figure 1 and figure 2, then it's going to be figure 1, because that talks about E. coli, and that's the right answer. That's how POE works, and that's how POE with PLR works. Then we get to question 5 with the fertilizer. Hopefully at this point we've calmed down. So okay, deep breath. We're going to use visualize, right? We're going to use the last step in Cali B. So here we go with the V. The V says if we add fertilizer to a river, fertilizer going in, what's going to happen? Well, water quality, which is being mentioned in the answers, is probably going to decrease. I think that makes sense. So if water quality decreases, that means it's not answer A, nor is it answer C, because those both say that water quality is likely to increase. We want the ones where it decreases. Okay, now what about the BI? Well, the BI is the water quality. So what we remember from doing number 3 is that, oh yeah, BI would go down because water quality goes down, because that's basically what table 2 and table 1 were showing us. So it's probably going to be answer D. That should take us around 4 to 4.5 minutes, right around there. What was really important is that we used S for L twice. The timing that we should be finishing this passage in is question number 5, because that's the last question, minus passage 1. So we should be done with this in about 4 minutes. 4.5 is acceptable. Let me just pause for a moment. Does anybody have any questions about what I just demonstrated? Is anybody there?
No questions.
No questions. Okay. What I want to stress is that there are a lot of markings going on the page, right? When we think through the science, we think with the pen on the paper. This may look like a lot of work, and it may seem really busy. Part of that is because I'm trying to explain it as I go, but you should be marking on the page, and you should be practicing that and getting better at it. The more you do that, the easier time you're going to have on the SAT and the ACT, and especially in the science. Yeah, I also want to talk just a moment on the timing. So again, if you're unsure about the timing, you just take a look at the last question. So here the last question is number 10, and it's passage number 2. So we should be through this passage by 10 minus 2 is 8 minutes. Passage number 3 is 16, and it's question number 3, or passage number 3. So we should be done with this one by 13 minutes, because 16 minus 3 is 13. So this is a running time. And you can see that when you get to the last passage, which is passage 7, you're going to be finishing question number 40, and it's going to be passage 7. So you're going to finish in 40 minus 7, right around 33 minutes. So you'll have an extra minute or 2 at the very end, because because it's designed to do that. If anybody has questions on the timing, let me know. But last question minus passage number, that's your running time. It's the best way to keep track that I know of. Okay, well, there's the trade secrets. So tell your friends. It's a video. You guys can use it. It's super helpful, and I hope that it gets shared with people.
All right, we had one question come in, Travis. When you save a question for later, do you recommend bubbling in an answer for that question or leave it blank until you come back to it?
Well, if you save it for later, you're going to want to take your best shot at the end, right? So you could bubble. If you have a good sense of what the answer is and you just want to double check it, then yeah, go ahead and bubble it. And if you've crossed off 2, then yeah, if you've got a pretty good guess, then go ahead and bubble it. But you probably don't want to bubble it until you've come back. If you're going to save for last, you can bubble it then, because there's a chance that you might not be able to come back to it. But if it's saved for later, you probably don't want to bubble it just yet, because most likely you're saving for later because you're kind of confused.
Yeah, I mean, I always tell students too that, you guys got to, even just bubbling in, you need bubble in practice. How are you going to do it? Do you do bubbles by a page? Do you do it by section? Do you do it after every question? You need to find what works for you best. I always like to do bubbling in, especially if I'm doing math, let's say, I'll bubble it in after like a page, if I finish a whole page or 2. It's just more efficient for me. It works for me that way. If I find a question that is confusing and I know I'm not even going to come back to it and do it later because I'm just so confused in it, I bubble an answer then and there. If it's a save for later, meaning that I need another chance at this, then maybe I don't bubble it in, is what kind of Travis is talking about. So just as he's talking about marking up a booklet as well, I mark that up. I know that when I look at a question, if I'm coming back to it, because I put a little question mark back on it, that's what I do for a save for later. If I know I've answered it correctly and I move on, I don't do anything with it. I bubble it in and we're done with it. If I cross it out, meaning that I'm not even going to go attempt it at all. It just doesn't work for me. So again, you need to find out your little methods and how you go about doing it, and find a plan that works for you. But that takes practice, guys. You just won't know how to do that tomorrow. You got to practice it. So
let me add on. It's not a bad idea to bubble on each passage, because if you're using PLR, you're probably going to go out of order anyways. And so it can be better just to bubble each time you go through a passage. So for the reading and the science, it's kind of good just to bubble each passage when you finish the passage. But if that makes you really uncomfortable, then yeah, just bubble each question. Each time you have an answer, then make the bubble if that makes you feel safe and confident. But you'll figure that out by practicing.
Yeah, a lot of the kids that I've tutored are probably the same way with you, Travis, is especially if you're going in different order, reading and the science and all that. It gets confusing. Oh, shoot, I got to do now 24, then I go back to 22 and bubble it in. So if you finish the passage, then it's just bubbling 21, 22, 23, 24, 25. So
instead of out of order.
Instead of out of order. It's just a little simple. It's chance of making mistake is less. So again, that's typically what our students would do. But again, you got to find what works for you. So, all right, last few questions before we let Travis go and myself. Other than that, everybody, thank you very much. You'll be hearing from me. I'll send you a follow-up email. Like I said, it would, if you wouldn't mind filling out the survey. And again, thank you, Travis, for the last 2 sessions. Really appreciate it. I know a lot of students got a lot out of that. And we'll be in touch. And everybody have a good night. Thank you. I'm going to stop the recording and I'll post it. Oh, we got something coming up. Oh, thank you guys. You're welcome. You're welcome.
Yeah, welcome.
So this recording will go up and it'll be in the student folder and you can watch it back anytime.